Hello, everyone, and welcome back. I am Dr. Supradip Das, Assistant Professor at the Department of Design, IIT Guwahati. And this is the 23rd lecture of the course Introduction to Toy Design. In this lecture, we are not just studying toys for special needs. We are changing how we think about design itself. We will begin by reframing disability, moving away from viewing the child as the problem and towards understanding the role of environments and products. Then we will identify different kinds of exclusion in play, not only physical but also social, cultural, and economic. Next, we will introduce universal design as a systemic approach to inclusion, including its origin and guiding principles. After understanding the principles, we will translate them into actual toy features so the ideas become actionable rather than theoretical. We will also discuss representation and accessibility and how identity and availability influence participation. Finally, we will examine real toy examples and analyze why they succeed in creating shared play experiences. By the end of this lecture, you should not only understand inclusion, but you should also be able to apply it. You should be able to look at any toy and identify who might be unintentionally excluded. You should be able to evaluate a toy using universal design principles and recognize where participation breaks down. More importantly, you should be able to modify or redesign a toy so that more children can engage meaningfully. You should also begin to design with shared play in mind, rather than designing for a single ideal user. And finally, you should start applying inclusive thinking not only to disability contexts, but also to culture, gender, access, and learning differences. In the previous lecture, we discussed designing toys for special needs. Today, we shift perspective. Instead of asking how do we adapt toys for certain children, we ask why were they excluded in the first place? Many barriers in play do not come from the child. They come from the design of objects and environments. Research in disability studies shows that disability emerges from interaction between people and barriers around them. If a toy only works for one type of user, the toy creates exclusion. Universal design, therefore, does not start with limitation. It starts with participation. We are not designing special toys. We are designing shared play experiences. Inclusivity is often misunderstood as integration. Placing children in the same classroom or giving them the same toy does not automatically create inclusion. True inclusion means the child feels they belong during interaction. It avoids labels like normal and special. Instead, it values difference as natural variation. Inclusive environments are designed so participation does not require permission or assistance. In toy design, inclusion means the toy welcomes different ways of playing, not separate versions, not alternative modes, but shared engagement. Inclusion is therefore an experience, not a feature. Integration asks the child to adjust to the environment. Inclusion asks the environment to adjust to human diversity. In integrated design, a child may be allowed to play but needs help to participate. In inclusive design, participation is natural. For example, a toy requiring precise fine motor control integrates some users but excludes others. A toy allowing multiple interaction styles include them. Inclusive design does not add accessibility afterward. It anticipates variation from the beginning. When we hear the phrase inclusive design, most of us immediately imagine disability. But inclusion in play is much wider than that. A child may be excluded because they cannot physically manipulate a toy. Another because they cannot interpret its rules quickly enough. Another because the toy does not represent their identity. And another simply because they cannot afford it. From the child's perspective, all of these feel the same. I can't participate. So, inclusive design is not about one group. It is about removing participation barriers wherever they occur. The important shift here is that inclusion is not tied to diagnosis. It is tied to access to experience. Designers, therefore, do not design for categories of children. They design for variability in children. So the keyword is variability. We have already discussed these in the previous lecture. So we will briefly revisit them together. Many toys assume a specific body size, grip strength, or coordination level. When interaction requires precision, some children are automatically left out. Some toys rely heavily on vision or sound. For child with sensory differences, the toy may either provide no information or too much information. Then there are toys that depend on fast understanding. If rules must be understood quickly, slower processors are excluded. Notice that in all these cases, the toy is not intentionally excluding. It is simply designed around an assumed user. And that assumption becomes the barrier. Inclusive design, therefore, widens the range of successful interaction rather than creating separate alternatives. Not all differences are visible. Some children process the same toy in entirely different ways. A child with ADHD may interact rapidly and exploratively. A child with autism may need predictability and repetition. A child with language difficulty may rely on visual structure. When toys assume one correct way to engage, they unintentionally exclude alternative thinking styles. Neurodiversity asks us to treat variation in cognition as natural rather than abnormal. So, inclusive toys support multiple ways of understanding: visual, tactile, exploratory, or rule based. Instead of asking children to adapt to the toy's logic, the toy accommodates different logics. Some exclusions are not physical at all, they are social. Children quickly learn which toys are for them and which are not. A boy may avoid dolls not because he dislikes them, but because the environment signals they are inappropriate. A girl may avoid construction toys for the same reason. Here, the barrier is expectation. Gender inclusive toys remove these invisible permissions. They allow children to explore roles freely. When toys avoid stereotype coding through color, narrative, and marketing, participation increases naturally. So, inclusion here is not about accessibility, it is about freedom of identity. Children also look for themselves in play. If every doll looks different from them, or every story represents another culture, play becomes observation rather than participation. Representation matters because play is identity rehearsal. When toys include varied languages, appearances, and stories, children feel recognized. Cultural inclusion, therefore, allows emotional entry into play. Some toys exclude through social structure. Games that rely on fast verbal response disadvantage quieter children. Highly competitive games may exclude anxious players. Group play requiring negotiation may exclude children with communication differences. These are not ability barriers, they are interaction barriers. Inclusive toys allow multiple roles. Children can observe, assist, lead, or collaborate. The goal is not equal performance, but equal participation. Think about open educational games used in classrooms. Simple card-based math games printed on paper. Every child can own one, carry it, share it, and replace it if lost. The learning spreads because the object is accessible. Compare that with an electronic learning device. It may work well, but only a few children interact with it at a time. The same applies to low-cost science models. Concepts like levers, pulleys, or planetary motion can be demonstrated using cardboard, strings, and bottle caps. Children can rebuild them at home, modify them, and repeat the experiment. Now consider indigenous material toys. Spinning tops made of wood, seed pod rattles, cloth balls, and bamboo flutes. They require no barriers, no specialized repair, and exist within the child's everyday environment. Here, inclusion comes from repeatability. If play depends on rare access, participation becomes occasional. Universal design, therefore, also asks, can the child return to the experience independently? Access is not only the doorway to play, but it also determines whether play becomes part of life or just a momentary activity. Across all these examples, a pattern appears. The same child can be capable in one environment and excluded in another. Ability is not fixed, it emerges in context. Inclusive design, therefore, works at the level of environment, not only at the level of product. When we widen interaction possibilities, more children succeed without needing special solutions. This becomes the bridge to universal design. We have spoken about inclusion as a value. Universal design is the design strategy that helps achieve that value. The term was introduced by architect Ronald Mace in the 1980s. He observed that environments built for average users constantly required retrofits for others. Instead of repeatedly fixing spaces, he proposed designing them from the beginning for human diversity. So, universal design means creating products and environments usable by the widest range of people without special adaptation. Now, is universal design the same as inclusive design? No, exactly. Inclusive design is the intention ensuring participation. Universal design is one systemic method to reach that intention. You can think of inclusive design as the philosophy and universal design as a structured toolkit. In toy design, universal design helps us avoid separate special versions and instead create toys naturally usable by many kinds of children. Traditionally, design handled difference through adaptation. A toy is created first, then special handles, supports, or alternate instructions are added later. This seems helpful, but it has limitations. Adapted products often separate users. Some children use the main toy. Others use the modified version. That separation communicates difference rather than belonging. Traditionally, design handled difference through adaptations also depends on supervision or setup. The child cannot independently participate. Universal design tries to remove the need for adaptation. Instead of modifying the user experience afterward, it broadens the experience beforehand. So rather than adding accessibility, we prevent inaccessibility. To make universal design actionable, 7 guiding principles were developed. They are not checkbox. They are lenses through which we evaluate interaction. Each principle addresses a different way exclusion can occur. Together, they help designers anticipate variation in ability, perception, and behavior. We will look at each principle and translate it into toy interaction. Equitable use means that different users can participate in the same activity without feeling separated. It does not mean everyone performs identically or that the toy needs to be made easier. It means everyone can engage meaningfully. Imagine a board game where one child plays directly and another uses a helper tool. Even if both technically participate, the experience is different. Children notice this difference quickly. They become observers instead of participants. Universal design aims to reduce that distinction. Instead of providing a special version, the same toy should allow multiple abilities to interact naturally. For example, a stacking toy that can be pushed, dropped, aligned, or arranged allows both precise and imprecise motor control to succeed. The goal is shared play, not identical performance. When a toy supports equitable use, children stop noticing who needed help. They simply play together. The goal is that no one can identify who the toy was designed for. The toy belongs equally to all participants. So, equitable use protects dignity in play. Flexibility in use is about allowing different play styles to coexist. In many games, there is a correct way to participate. Follow instructions, take turns quickly, respond verbally. But some children observe longer before acting. Some act physically rather than verbally. Some repeat actions rather than progress. A flexible toy accommodates these patterns without stopping play. For example, a building toy that can create a structure, pattern, or story scene lets different children engage at different cognitive and social levels. The same toy supports competitive play, a collaborative play, or solitary play. Flexibility, therefore, prevents exclusion caused by behavioral expectations. Simple and intuitive use is about removing culture and experience barriers. If a toy depends on language ability, reading ability, or prior exposure, some children begin at a disadvantage. An intuitive toy communicates possibility immediately. For instance, shape sorter are played correctly across cultures because their rules are embedded in the object itself. No translation is required. No adult mediation is required. This principle ensures that entry into play does not depend on background knowledge. The toy invites participation universally. Additionally, when toys require adult instruction, independence decreases. Instead, form should communicate function. A protruding button invites pressing. A groove invites sliding. A hole invites insertion. Children naturally interpret physical cues. When interaction depends on reading or remembering instructions, play turns into a task. Simplicity does not mean lack of depth. It means the first step is obvious. Complexity can unfold after engagement. So the toy teaches through interaction, not explanation. Perceptible information ensures that participation does not depend on one sense, and that feedback should be noticeable regardless of sensory preference. Consider a game that signals success only through sound. A child in a noisy environment or with hearing difficulty misses the event. Now the game pace changes for them alone. If the same success is shown through movement or color change, everyone stays synchronized. Perceptible information, therefore, keeps players in the same shared moment. The goal is a synchronized experience, not just detectable feedback. When multiple sensory cues confirm the same event, interpretation becomes reliable. For example, a click plus movement plus color change communicates clearly. This redundancy reduces doubt. The child does not need to check repeatedly. They trust the interaction. The aim is not to overwhelm with signals, but to ensure at least one channel is perceivable. Tolerance for error is about protecting confidence in social play. In many games, mistakes eliminate players. Elimination creates spectators. Universal design avoids removing participants. For example, instead of "you are out," the game might convert mistakes into a new role or alternate action. The child stays part of the activity. The principle preserves belonging rather than performance. Additionally, children learn through experimentation. But if mistakes immediately stop the activity, exploration decreases. A toy that resets progress after every mistake teaches caution instead of curiosity. Tolerance for error allows safe failure. The child can try again without losing engagement. This builds confidence. Importantly, tolerance does not remove challenge. It removes punishment. The child feels encouraged rather than judged. Low physical effort here is not only about fatigue. It is about fairness in duration of participation. If interaction requires high strength or precision, some players drop out early than others. The game continues, but without them. When effort becomes exhausting, play shortens. Children then rotate away from the toy quickly. Low effort ensures duration. The toy should invite sustained interaction, not a quick demonstration. Designing for comfort increases depth of the play and ensures everyone can remain engaged equally long. So the goal is equal opportunity to continue playing. The seventh principle, size and space for approach, ensures that appropriate size and space are provided for approach, reach, and manipulation and use. Regardless of user's body size, posture, or mobility. This principle accommodates varied user needs, including seated or standing users and those with assistive devices. One should ensure a clear line of sight, comfortable reach, accommodation of variations such as grip, size, and adequate space for the use of assistive devices for personal assistance. Children interact from many positions. They kneel, lean, lie down, or reach sideways. If the toy only works from one angle in so much space, some users struggle. Providing spatial flexibility supports participation. The toy does not demand a posture, it accommodates posture. This principle becomes especially important in shared play environment. These three terms, universal, assistive, and accessible design, are often used interchangeably, but they describe very different design philosophies. Assistive device creates a dedicated product for a specific group. For example, a communication board made only for non-verbal users or a special switch operated toy created exclusively for children with motor impairment. It works well, but it separates users into categories. Accessible design takes an existing toy and modifies it. Imagine adding a large grip adapter to a small puzzle piece, or attaching a braille label into an already printed board game. The toy becomes usable, but the modification is visible and sometimes dependent on assistance. Universal design works differently. Instead of altering after the fact, it anticipates variation before making the object. In design, we often celebrate usability. If the child can operate the toy independently, we call it successful. But play is social before it is functional. Imagine a child who can operate a specialized toy perfectly, yet cannot join a group game because it works differently. The toy is usable, but the child is still excluded. Now imagine a board game with simple shared mechanics. One child understands rules immediately. Another learns slowly. A third plays by observing and imitating. All remain part of the activity. That is participation. Participation means the toy supports belonging, conversation, and shared imagination. For example, a collaborative building set where children contribute differently. One sorts pieces, one assembles, and one narrates. Enables participation even with unequal abilities. A toy that requires identical performance from everyone may be usable but can still exclude. Universal design, therefore, measures success differently. Instead of asking, can each child operate the toy? We ask, can children play together meaningfully? Because in play, inclusion is not independence, it is connection. When we say a toy is inclusive, we often think about who can use it. But universal design asks a slightly different question. How many ways can someone enter the play? Universally playable toy does not begin with instructions. It begins with invitation. One child may start by exploring randomly. Another may observe first and then imitate. Another may follow a pattern or goal. All of them are participating meaningfully. For example, a set of open building blocks can be stacked, arranged, sorted, counted, or used in pretend play. Each approach reflects a different developmental and cognitive level, yet no one is excluded. Universally playable toys, therefore, do not define a single correct starting point. They allow players to meet the toy at their own level. The success of toy is measured not by mastery, but how many people can meaningfully begin playing without help. These can be done in multiple ways, such as affordances. Affordances are cues in the object that suggest how to interact with it. A handle invites pulling. A hole invites insertion. A soft object invites squeezing. When affordances are clear, children do not need explanations. This becomes important for inclusion because instructions often exclude. If understanding depends on language, memory, or prior experience, some children start later than others. But if the toy communicates through its form, everyone starts together. Think of a rolling ball track. Even before understanding the goal, children know to release the ball at the top. The object itself teaches the rule. Affordances, therefore, remove the barrier of instruction and replace it with discovery. Universal design relies heavily on affordances because this equalize entry into play. Different children rely on different senses during play. Some watch carefully before acting. Some rely on touch. Some respond to sound. If a toy communicates through only one sensory channel, participation becomes uneven. Multisensory design ensures information reaches players through more than one pathways. For example, a peg fitting into place may click, align visually, and change resistance simultaneously. Now the outcome is understood regardless of sensory preference. Importantly, multisensory does not mean overwhelming. It means reinforcing the same message across channels. The child does not need to check repeatedly because confirmation is clear. This keeps all players synchronized in the same shared moment of play. Many toys are excluded not because of physical interaction, but because of rule rigidity. If success depends on one precise outcome, only certain players experience achievement. Open-ended toys distribute success differently. One child may build a tall structure. Another may sort colors. Another may create a story. All are valid play outcomes. Flexible rules allow players of different abilities to remain engaged together. Instead of measuring who wins, the toy supports shared activity. This principle is especially powerful in mixed age or mixed ability settings. The toy becomes a platform rather than a test. Universal design, therefore, reduces competitive exclusion by expanding definitions of success. One of the strongest indicators of universal design is transgenerational play. When a toy can engage different ages simultaneously, it is naturally inclusive. A toddler may explore sensory qualities. An older child may construct strategically. An adult may engage socially. The same object supports different cognitive levels. This reduces the need for specialized toys per age group and encourages collaborative interaction. Shared play across generations also removes the helper versus player dynamic. Everyone becomes a participant. Universal design, therefore, does not only include different abilities, it includes different life stages. So far, we have spoken about entering play physically and cognitively. But inclusion also has an emotional layer, recognition. A child may operate a toy perfectly yet never feel the toy belongs to them. This often happens through representation. If every character in a toy looks similar, some children becomes observer rather than participants. Representation is not decoration. It signals permission. For example, dolls with varied skin tones, wheelchairs, hearing aids, or different cultural clothing communicate that many identities are part of normal play. Children rehearse social understanding through toys. They practice roles, empathy, and belonging. When diversity exists in the play world, difference becomes familiar rather than exceptional. Importantly, representation benefits all children, not only those represented. It expands the imagination of society. So, universal design includes not only multiple ways to use the toy, but also multiple ways to exist within the toy's narrative world. Inclusion is complete only when interaction and identity are both accessible. Inclusion does not end at usability or representation. A toy can be perfectly inclusive in interaction and still exclude children who cannot regularly access it. Access is a design decision. If a toy requires expensive electronics, special batteries, a large dedicated space, or constant supervision, many children interact with it only rarely. And play that cannot be repeated does not become meaningful play. Universally designed toys consider everyday environments, homes, classrooms, outdoors, and shared spaces. For example, modular toys made of durable, repairable parts remain usable even after damage. Loose part toys made from simple materials can be replaced locally rather than discarded. Affordability is not about making toys cheap, it is about ensuring continued participation over time. When access depends on privilege, inclusion becomes temporary. So, universal design extends beyond the object itself into distribution, maintenance, and context of use. Inclusion means a child can return to the same play experience again and again, not only encounter it once. Uno is already a social game. It depends on reading numbers and colors and reacting quickly. For a visually impaired player, the traditional game requires constant assistance. Someone must read the card aloud, which changes the social role of the player. The Braille Uno cards change only one thing: the information channel. Numbers, colors, and commands are embossed onto the same cards. Now, a blind player reads independently, while sighted players continue visually. Notice what is powerful here. The rules did not change. The pace did not change. The social structure did not change. This is universal design rather than adaptation. There is no special deck used separately. Everyone uses the same object. So the design preserves dignity and equality in play interaction. The lesson here is that inclusive design should modify information delivery, not the shared experience. Learning toys often rely on instruction and correction. But correction depends on language and attention span. This puzzle instead uses structure as feedback. Pieces only fit correctly in one arrangement. The toy itself provides confirmation. Children with different processing styles, visual learners, tactile learners, and slower processors all receive the same guidance. Importantly, no one is told they are wrong. The object communicates it silently. The learning becomes self-paced. Universal design here removes dependency on explanation. The toy becomes the teacher. For decades, dolls reflected only a narrow appearance. Children who did not resemble them played as outsiders in the narrative. Black Barbie changed not the function of the toy, but its cultural meaning. Later expansions added diverse body types and appearances. Now the toy reflects society rather than prescribing it. Representation enables emotional participation. A child who sees themselves in play imagines themselves in possibilities. Universal design therefore includes psychological accessibility, not only physical usability. Many toys become global, but not all become inclusive. What makes the difference is whether the toy adapts the meaning while keeping play shared. Construction systems like Lego demonstrate inclusion at the world level. Children everywhere use the same bricks, the same connections, and the same building logic. No one has the realm how to play, but the stories are built on top of that system change. A Russian street, an Indian vehicle, a city apartment, a safari camp, or an indigenous tent. This gives children the opportunity to see their own lives reflected without being separated into a different toy category. Barbie demonstrates inclusion at the identity level. The play pattern remains identical: dressing, storytelling, and role play. But the characters now represent different skin tones, body type, abilities, and professions. Earlier, many children played through the doll. Now, they can also play as themselves. Together, these examples show an important design principle. Inclusion does not always require changing mechanics. Sometimes you keep the system universal and allow narrative and identity to vary. This allows children to recognize themselves in the toy while still sharing play with others. So, universal design in toys operates at two layers. First, shared interaction, and second, diverse representation. Representation becomes especially powerful when it includes disability. Historically, disability in toys appeared mainly in medical or therapeutic contexts. That meant the child interacted with disability only as a condition to be treated. More recent dolls include wheelchairs, prosthetic limbs, hearing aids, and mobility aids within the same toy line as all other characters. Nothing about the play pattern changes. The doll still participates in storytelling, fashion play, friendships, and adventures. This is important because the toy does not become a special teaching object. It remains a normal character. For a child with a disability, this communicates belonging. Their identity exists naturally within the play world. For other children, it normalizes diversity without instruction. They do not learn inclusion as a rule, they experience it as ordinary. Universal design here operates at the social perception level. The design does not adapt the user to society, it adapts society's imagination. The key lessons for designers is that inclusion is sometimes achieved not only by altering functions, but by altering what is considered typical. Most toys are not neutral objects, they carry signals. Pink packaging, action themes, beauty themes, combat themes, and nurturing themes communicate expectations before the toy is even opened. Children quickly learn which toys belong to them and which require permission. Some of the barrier is not mechanical ability, it is social permission. A girl may avoid construction toys not because she cannot build, but because she believes she is not meant to. A boy may avoid caregiving toys not because he dislikes them, because he anticipates judgment. Over time, this affects skill exposure. Some children get more spatial reasoning opportunities. Others get more social or narrative practice. The toy has now influenced learning pathways. Importantly, children rarely experience this as restriction. They experience it as preference. Universal design, therefore, examines not only whether a toy can be used, but whether it invites everyone to try. When a toy quietly signals not for you, participation ends before interaction begins. Therefore, inclusion is influenced not only by toy design, but also by presentation. Brands can avoid labeling toys as boys or girls' toys and choose to be gender neutral. Instead, they categorize by age and interest. This removes the permission barrier before play even begins. Children choose based on curiosity rather than expectation. Universal design therefore includes communication design, the system around the toy. Another option is to gender inclusive. This modular figure set combines traditionally gendered elements, skirts, helmets, heels, and tools in any configuration. Children cannot assemble a strictly male or female character. So instead of instructing inclusion, the toy demonstrates it. The design does not remove identity, it expands it. Here, universal design operates at the symbolic level. Participation includes emotional permission to imagine oneself in any role. The lesson here is that inclusion is also about the stories objects allow. Many toys exclude through age rather than ability. Children outgrow them quickly, requiring replacement. The transformable bike changes form as the child grows. It supports early balance training and later riding skills. This extends participation over time. Neutral aesthetics also avoid gender coding. The toy remains relevant to different children across development. Universal design here addresses temporal inclusion, not just who can play, but for how long. So today's lecture asked a different question from traditional design. Not how do we help some children play, but why were some children excluded from play in the first place? We saw that exclusion often does not come from the child. It comes from assumptions built into objects and environments. Universal design, therefore, shifts the role of the designer. We are no longer adapting products after failure. We are anticipating diversity before creation. We explore how inclusion operates at multiple levels: interaction, perception, identity, and access. A toy becomes inclusive not when everyone performs the same way, but when everyone can participate meaningfully. We also saw that inclusion benefits everyone, not only a specific group. When more children can engage, social play becomes richer. So, inclusive toy design is not a constraint on creativity. It expands possibilities for interaction and imagination. As designers, when applying universal design guidelines to our products, our goal is not to design for an average child, but to design for the range of childhood itself. That being said, universal design is a choice of intention, but design does not always need to be universal. There is also value in focused design. Toys made specifically for children with certain abilities, therapeutic needs, or learning styles. Specialized toys can offer depth, precision, and support that broad products cannot. So the goal is not to replace niche design with universal design, but to understand when each is appropriate. As designers, we choose the scope of participation we want to enable, because ultimately a good toy is not defined by how many it serves, but by how thoughtfully it serves its intended players. As you move forward in your design journey, keep reflecting on the topics we discussed. Let these aspects guide your creativity and decisions as you continue shaping the future of play. And until we meet again, keep your ideas inclusive, your thinking open, and have a wonderful playful time.